All right, so I just started the live stream here, folks. Good evening, everybody. Welcome to my YouTube channel. Tonight, we are live streaming from the Westwood Library in Westwood, New Jersey. So I'm going to, at least from the very start, so I don't make this mistake later, because I do this all the time where I forget to bring the window up. So I'm going to just bring the window up front and center, and then just start yapping. All right, hang on a second. So there we go. I'll bring it up full screen in a second. So thanks everybody for coming. Welcome. It's great to have a nice crowd. My name is Joe Chaffee. I've been around quite a while. For those of you who have listened to New Jersey 101.5 radio, I was a fill-in there for Alan Casper, who is the reason why I'm doing this to begin with. 40 years ago in August, I think it was in August. Yes, 40 years ago in August, coming August, uh, I was finishing up an internship at the National Weather Service in New York City, which at the time was in Rockefeller Center. And for those of you who are old enough to remember telephones that had multiple lines and they had the buttons with the lights, and I had to I picked up the phone to make an outside call, but I picked up a phone that he was on the line on hold. And we started talking, and I was always very much a big fan of his. Uh, he was the go-to guy at the time. If you were a snow lover, he was the go-to guy that uh, the young folks would watch, just glued, because he was such a good forecaster. And he's still around. I don't want to make him sound like he's disappeared off the face of the earth. But I just happened to pick up the phone. We got into a conversation. I mentioned that I had just finished up my internship and was going back to school. He mentioned to me that Nick Gregory, who's on Channel 5 and still is, was going back to school as well. And he was going to be, he had an opening for a paid intern position. So I went over to Channel 2 after I finished my internship, and that started what is now going to be my 40th year in television. So I've had kind of a really odd career in a lot of ways, because I started in New York off air. I worked on the Today Show for 2 years with Willard Scott, which was a really terrific, it was a terrific television experience working with him, because he was all about TV, and that was part of what I needed to learn was how does the TV part of it. It's all fine and dandy, the weather part of it, but at the end of the day, if you're on television, you have to sell your product. And he he's a great showman, and he taught me quite a bit. And then I went to Corpus Christi, Texas for a couple of years to cut my teeth on my own. I adventured to New Orleans for 3 years and worked at a television station, WVUE TV in New Orleans. When you work in New Orleans, you don't really work. It's for those of you who have been there, you kind of understand it. It's very much a fun city. Of the many places that I've been to, if there was one place I could have really spent my life at working, was in New Orleans. It's the only place that you wake up in the morning and every recipe starts with 3 sticks of butter, and at least a quart of cream. Yeah, you would go to somebody's house and you're dropping kids off at the bus stop for the bus, and somebody's got a container with Bloody Marys all ready to go. I mean, it's just the mindset of New Orleans. It's very much a party city. Humidity and hurricanes? No, actually, in the business of television, you get new management. They want to do different things. I lucked out because when my contract was up from there, I landed a job at News 12 Long Island. They were launching News 12 Long Island in 1986, so I was one of the originals there. I was there for 10 years. Then I went to WPIX TV, where I spent 11 years plus there. And that was the best, from a job perspective, that was the best time I had from a work perspective working there. It was an easy shop. You did your work, you went home. I never came home aggravated, never came home stressed. And then from there, when the 2008 bubble housing bubble burst, so did the television industry bubble burst, and I found myself working at the IRS in on Long Island, where they have one of their main offices, because at the end of the day, you have to eat. And it was, I was older, so it was tougher. But I gradually found my way back in. I still was going on New Jersey 101.5 through all of these years, and then I wound up back at Channel 11 doing freelance, and then I wound up with a primetime position at FiOS One News, which is where I've been for the last almost 5 years. So it, like I said, kind of unorthodox, as I've been all over different places and I've experienced a lot of different things. So, those of you who don't watch on a regular basis and know that I lay out a pretty much a weather program. I have a YouTube channel, which we're on right now. For those of you who come in late, don't worry, the camera's pointed this way. It's not pointing out at the audience, so you're all good. Um, I do have a YouTube channel where, believe it or not, I wind up usually going on for about an hour or so every night talking about weather. And I'm amazed at how many people actually sit through the whole hour, because you know, it's it's not it's not Netflix, okay?
Very interesting.
It's interesting from a weather perspective, and I'm glad that the weather people have kind of gravitated to it. If you are on there, you can join in on the chat. Just you subscribe to the YouTube channel using your Gmail address. It's absolutely free, and this way, if you want to participate in the chat, shoot me questions, comments, whatever it is. I always welcome that. I'm on Facebook, meteorologist Joe Chaffee. So you can find me there. My Twitter handle is @Joe Chaffee, although I don't spend a lot of time on Twitter. Uh, I don't like the Twitter platform for weather. I don't think it's a good platform for weather as a whole. So I also have a free app. So for those of you who don't have my app, you need to download it. Okay, it's absolutely free. It's on Google Play and it's on the App Store. It's on Google Play as Joe Chaffee. It's on the App Store as meteorologist Joe Chaffee. So uh, we'll get started. I thought what I would do is, we've got this big storm out in the Great Plains. It's a typical springtime storm, so I thought it would be a good idea to we'll start with that. We're going to do a little bit of upper air analysis. We can talk about the winter that's passed, and why things turned out the way they did, and we can also look back. We've got the anniversary of the '93 superstorm, so we can look back at that. I also, I have a lot of different websites that I use that are all available free, and if you're into weather, some of them you may be familiar with, some of them you may not be. But one of the real pluses we have, I have an audience that watches from Ireland and from England on my YouTube channel, and the one thing that they tell me is that they beg for weather information there. Their government websites provide so little weather information and tools for folks to use. When you go to Met Arian, which is the one for Ireland, it's basically icons with numbers. And when they give alerts, there's they have this color code. They have the yellow alert and the orange alert, but they don't get into the specifics. Access to satellite data and radar is very tough, and access to weather models is also very tough. And these are people like you. You're very interested in what's going on weather-wise. So our National Weather Service just blows them away when it comes to all the stuff that they do. And once upon a time, there was an adversarial role that existed basically between the TV folks and the Weather Service. And sometime around the early to mid 1990s, that adversarial role kind of went away, and it became much more of a cooperative type of relationship. And now it's really evolved into this really excellent relationship that we have with the Weather Service in general, because they provide the stuff that we always did that they never did. So now they're putting up snow maps. They're putting up a lot of things in the public domain. They're very active at their websites and social media. So they are certainly much more of a hand-in-hand relationship that we have with them, and I applaud it because they've put up, they've got so many great tools that we use. For instance, for severe weather, this is from the Storm Prediction Center, which is spc.noaa.gov. Now, the Storm Prediction Center's responsibility is just basically severe weather, and what we're looking at is a real-time radar loop, and superimposed on this is the severe weather risk. Now we've got this major storm that's in the Great Plains, and as a result, the Storm Prediction Center, during the course of the day, usually twice a day, they will put out their general outlook for severe weather, and it's marginal risk, slight risk, enhanced risk, moderate risk, high risk, and I think there's even one more above that, which I've never seen. I don't know if they go to extreme risk or not. So we actually, when you see enhanced risk, that's a pretty strong risk for severe weather. It's concentrated in west and central Texas. The red box that you see, what looks like a box, sort of like this amorphous rectangle, that is a tornado watch that was just issued during the time of the loop. So it actually was issued roughly at about just a little bit before 2200 hours, which was at 6 o'clock this evening. So about a little over an hour ago for eastern New Mexico and West Texas. So this is, in the springtime and into the early summertime, the Storm Prediction Center comes front and center as far as weather is concerned across the United States. For us, for severe weather, for our neck of the woods, we're a little early. Usually for this area of the Northeast, it's more like May and June, and particularly the latter part of May and June, that we really start to get into July, that we start to get into severe weather. And obviously, we do occasionally get tornadoes up here, but it's not of the magnitude like they're going to see that they see down in the severe weather world. So this is their assess risk. That large area that you're seeing here, that's their general area of thunderstorms. So this is again at the SPC, which is spc.noaa.gov. And any of the links that I mentioned, if you forget, you can always just message me, and I'll let you know what's happening. So let's take a look at what's going on current weather-wise at the moment. And I'm going to take you through. We'll take you through current weather, and then I'll show you some of the weather models we use, and what all the stuff means, because a lot of it can be very daunting, and it is technical. It is very technical, but there's a way that you can look at this stuff and get a general feel for how weather works. One of the things I say I try to get everybody to kind of focus on is the fluid nature of what meteorology is. I've often, and you said it from the beginning earlier tonight, meteorology is not an exact science. I've always changed that view a little differently. It's the laws of thermodynamics, the laws of the atmosphere, the laws of energy, those are kind of set in stone, okay? So that is exact. What's not exact is the fact that what meteorology really is about change. It's about the change of every molecule in the atmosphere, okay? Changing every second of every minute of every hour of every day. And the problem is that the change is changing. The rate of change, the magnitude of change. And you're asking, when you ask, well, what is the forecast? What you're really asking is, what is the change of every single molecule of my entire world, okay? The whole world. And how does it, and then you got to bring it back down to my zip code, Okay, so there has to be a little bit of latitude in terms of a margin of error when it comes to this sort of stuff. And it's tough because as you start to go further and further out in time, it's like a giant V. Okay, you're going to have this um, V-shaped expanding V, and the distance between one arm of the V and the other is the the difference, the expanding differences of weather outcomes. As you go out longer and longer in time, there's more and more variabilities. The variability gets larger and larger and larger. So this is why your 2-day forecast is far more accurate than your 5-day forecast, which is far more accurate than your 10-day forecast, which most of the time is not going to be very accurate, which is even more accurate to the almost non-accurate 16-day forecast and the non-existent accuracy rate of 3, 6, 9 and month and down the road, other than trying to give a general overview. So yes, Scott, go ahead.
That's what ask a question. I've been following you for a couple of years, and like when the GFS model comes out with like a 16-day forecast, it's never right.
And nor should it be, but go on.
Right. But what is the purpose then, except for showing things in advance or people hysteria? Why would the Weather Service even issue such a?
Okay, so hold that to when we get to the models, and then and then we'll address it. Okay, so one of the other things is as we start looking at all this stuff, and I'm kind of going to take you through the process of what I go through all day long, but I would just say this: there is a lot out there in terms of information. Okay, to the point where it's not long that you suddenly don't even realize what it is you're listening to. And you're so overwhelmed by all this stuff. And, they said, I often kid about unauthorized meteorology that's practiced every day on supermarket checkout lines. Okay, where I'm standing there. Look, I don't make any assumptions that people, most people don't know that I work on TV. I'm the guy that's standing next to them that's got a frozen leg of lamb in his hand. But and there's a reason it's a frozen leg of lamb. So I'll be standing there, and I'll hear, well, they said. So now I'm a pronoun. Okay. A gender neutral pronoun nonetheless, but it's a pronoun. And they said, and then they'll come out and I will hear unreal stuff. I mean, just really unreal stuff. A coating to an inch, okay, becomes, a 30-meter snowstorm reaching beyond the, halfway up the Empire State Building. Okay, therefore we must clean out the store. See, I have this idea. I have deputized basically all of my followers that if you're standing on a supermarket checkout line with a frozen leg of lamb in your hand, you gently pull that person aside and very kindly just say, no, you obviously are practicing unauthorized meteorology. Give them the correct view of the forecast. And then you take the leg of lamb and you just swing it right at them and just floor them. Okay? Because, and make sure you have no witnesses when you do this. But seriously, it's very frustrating for me because I am really trying to be pretty precise, okay, with regards to the information that I'm giving out. And you, as a consumer of this information, should really demand that preciseness from somebody. And the problem is that everybody forecast shops. You do. If forecast shopping were shoes, oh my, it's insane. And it becomes this sort of, especially when in the wintertime when it's for snow, it becomes this sort of comparison game. Who's got the highest numbers? Who's got the lowest numbers? And then I will get so and so is going 6 to 12, and you're only going 3 to 6. All right, well, Why are you telling me this? I've been trying to, I'm trying to figure out sometimes what is the motivation behind getting there. Is it because they really want the 12? They don't want the 6. Do they really want the 12 because they want the snow day, or they want the, not go to work? I don't know what the motivation is. But what concerns me is, this sort of broad misinformation that gets out there, and you wind up with roads being brined in southern New Jersey when the temperature is 50 degrees and higher because of what happened back in November. Okay, a purely what should have been what should have been a manageable event became a big problem because it's November and municipalities do not budget for snow removal in November. Okay, so just so we're clear, you might I don't you might okay, but in general, municipalities don't budget for snow removal in November. Why? Because municipalities and we all know that snows in November don't happen that often. All right, especially during the first half of the month. Every 10 or so years, you get one, close to Thanksgiving or a little bit better. But for the most part, most Novembers, it's quiet. So this was an anomaly. But what I didn't understand was the fact that the night before, there were winter weather advisories that went up for New Jersey, for northern New Jersey, for a 2 to 4 inch snowfall. Okay, so this was no secret, but it became this mess, and it's all based on the fact that they don't budget. If they don't budget, they're not going to spend the money to brine. They're not going to go out be ready. It's one of those things that happens. Everybody's in an uproar, okay, over what should have been something maybe not completely manageable, but somewhat manageable, and you go on. So now we've gotten to this point where it seems as if we will eventually get to a time where it will be completely unacceptable at any point in the wintertime for a single snowflake to touch the ground. We are going to have to hire government people to stand outside and catch snowflakes before they hit the ground. Honestly, it's snow. It melts.
Joe,
If it
Friday
does,
night when we got 17 flakes, they were brining that Friday.
no, I know. Listen, this is because now, like as I said, it's become this sort of overreaction. Hopefully, a nice, long, hot, humid summer will get it all out of everybody's memory, and we'll start all over again. But just my point is, be very, very careful in terms of how you consume information. Please, if you do have to forecast shop, limit it to, a couple. Use the weather service and, maybe one other person, me. No, I'm just kidding. But no, the weather service, and you got a couple of, there are a number of reputable people in this area that do great weather work. Pick one or two and kind of stay with them, and stay away from the apocalypse. Okay. The apocalypse predictors. Everything is an epic storm. Everything is a storm of the century. Here's the problem with predicting the apocalypse. You can only be right once. Okay? So apocalypse forecasting is nothing. Plus, you want to be able to rely on somebody that doesn't predict the daily apocalypse, so that when he does actually predict the apocalypse of some sort, relatively speaking, it's not really an apocalypse, but you get my point. When there's a Hurricane Sandy coming, when there's a big potentially crippling snowstorm that's going to keep you from getting out of your house for a day or two. You want to be able to rely on somebody that's going to say and have confidence that what they're saying is going to happen, so that you can make whatever decisions you need. Particularly when it comes to a hurricane and you're on the if you're at the shore, you want to have good information. So here's what's happening tonight. Let's start where the weather is nice, and that's over us. What I have here is something that the Weather Service provides for those of you who are into looking at weather maps. This is a surface map. A surface map, they take surface observations from airports all around the United States, temperature, dew point, the pressure, wind direction, speed, and then a few other details, sky condition, and so on. They plot it on a map every 3 hours. and then somebody gets to play connect the dots. Those lines that you see there, lines of equal pressure or isobars, that those equal pressures that are measured, they connect them so we can find out where all the high pressures are and the low pressures are. This is a weather service tool that updates every 3 hours. It has a library that goes back to the early 1980s, so you can pull up any storm you want if you know the date and watch 3 hour sequence of maps. And we actually can pull up. I'll pull it up later. We can look at the superstorm of 1993. But we've got this nice little high sitting in Ohio. Our weather here is very, very nice. The atmosphere always has to be in a state of balance, and that could mean that that it can be in an extreme state in one place and in a non-extreme state in another, in order to achieve this sort of equilibrium. So where it is out of balance right now is out in the west, and particularly in the southwest, where we have energy swinging out. And you can see on the latest analysis here, let's see if it's too early. Oh, we got the new one. So here's the very latest map, that surface map plot. So you've got several lows, from one in Nevada, another one in southern Utah, one in northwest New Mexico. And it's this low that's in southeastern Colorado that's going to wind up developing into a major storm overnight and on Wednesday. This is going to be a huge storm for the Great Plains, and it's going to have some interesting implications for the northern plains, because they have been frozen for the last 6 weeks, and the ground is like cement. On top of that, they have seen record snowfall from the western Great Lakes across much of the northern plains. The snowiest Februaries on record. For many of these areas, it's going to be the snowiest winters on record. We have to remember, by the way, that the entire world does not rotate around the axis of the I-95 corridor. Okay. What is, well, I bring this up because I wanted to, I kind of blew a small mini gasket, let's say. Obviously, we have been in a bit of what I've been referring to as being in a bit of a snow hole, that we are, here in this stretch from about Philadelphia, or just north of Philadelphia, to New York City, to Boston, to Portland, Maine. That snow hole actually has shrunk down considerably. Go north and west by about 75 or so miles, and go north and west of that. The snowfalls actually this winter across the interior Northeast and on up through central and northern New England have either been near or actually running in some places above average. You go out west, it's been an absolute clobbering in the Northwest, in particular, in the coastal Northwest, in Seattle, which, their annual snowfall in Seattle is, and considering how far north they are, you'd be shocked. Their average annual snowfall in Seattle is 6 inches for the whole winter. Okay. So when Seattle gets 22 inches in 1 month, or whatever it was for the month of February, when Seattle gets 22 inches of snow in the month of February, which I think was their all-time snowiest February ever, and one of their all-time snowiest months ever, that's a big deal over there. Much of the northern plains in Minnesota, you'll be surprised to know that in Minneapolis, that the average snowfall in Minneapolis in the month of February is actually half of what it is here in New Jersey. Because in the depth of winter in the northern plains, it's so cold and so dry that it really doesn't snow very much in most years. Up in the Dakotas and in Minnesota, they get a lot of snow early and late, but in the trough of the winter, from the coldest part of the winter, from January to about mid-February, there's actually a drop in snowfall. They get big amounts on either side and smaller amounts in the middle. Well, this year it's flipped. They actually got probably average amounts going in, and then it went up this way. So it was really unusual for them to see big snows like they've seen. And I have friends up in Wisconsin, and actually my nephew lives in Madison, and they've got like 3-4 feet of snow cover on the ground just laying there from storm after storm after storm. But this storm in the west is going to be a big deal. So I'm going to take you through what's happening with regards to this. We have what I've brought up. This is a website for those of you who haven't. Oh, by the way, just want to say hi, Northern New Jersey Weather Observers. Hands up. Awesome. Nice to see you guys all here, and ladies too. Okay, so website aside from weather.gov, which is could be easily your start page. Like that's what weather.gov looks like. In case you've never seen it. Now, each of those colors represents warnings and watches that are up, and you can see on the bottom what they are. But I'll just run through them real quick. The green are flood watches. The dark green are all flood watches. You'll notice that the flood watches are up where? Wisconsin, Minnesota, northern Iowa, and why? Deep snow cover. Deep snow cover, also cement ground. It's been so bitter cold up there. Remember, these are areas that while we were getting our cold air masses were in double-digit below zeros, especially at night. So the ground is like absolutely frozen solid concrete. A lot of these areas have 2 to 3 feet of snow cover on the ground. Now you're suddenly, for the first time in quite a while, and certainly for the first time probably in this area since mid-January, you're taking temperatures up above freezing very, very rapidly and putting down 2 inches of rain that has no place to go and the beginnings of snow melt. So there probably will be some serious flooding implications from this storm. And also going forward with any new storms that go up into the western lakes are going to probably cause some serious flooding this year from snow melt up in that area. The orange is blizzard warnings, and you can see extensive area of blizzard warnings. The salmon pinkish color, those are winter storm warnings. The darker blues are winter weather advisories. The lighter blues here are winter storm watches that they have up. The brown and yellows are either high wind watches or high wind warnings. And also you have wind advisories. So all the action there is concentrated out west of the Mississippi River. So if you've got an intense storm in the west, you usually have quiet times in the east. When you have storms in the east, you usually have quiet times in the west. That's how the atmosphere works. It's never, you're never having horrible weather over the entire geography of the U.S. from one coast to the other. You can have stuff happening on both coasts at the same time, but we're 3,000 miles across. The way weather works, it's likely that there's going to be a calm spot in the middle, and weather's always about going from one, push and pull, one extreme to the other. You can also, if you go to the bottom here, you can find links to all the different weather service, sites that you want, including the National Hurricane Center, the Storm Prediction Center, which I pulled up before. I'll just bring it up again really quick. You can see the Storm Prediction Center's full website page, and they come out with all these discussions on the side, the individual tornado watches. So if you ever want to read them, some of them are kind of they're on the high technical side, but my view is if you expose yourself to weather, you just keep reading more and more of this, and then just kind of filter a few questions to someone who can help you with it, which I'm always around to do, and more than willing. A lot of this stuff starts to light bulb, okay? And you suddenly start to get it, and you can begin to have more fun with trying to, forecast your way into the future. But just be careful, because it doesn't always necessarily work out the way you'd like. Let's take a look at some satellite stuff. I forgot to bring those up, but we're going to take a look at the new GOES 17, which is just an amazing. Where is it? I got it here someplace. No, that's not it. Whoops. Hold on. I'll do it this way. Hang on. Weather.gov. Yes, thank you. Exactly. I'll actually go through it a different way. I'll pick out just for laughs. You've got 2 local offices for the Weather Service. So you've got Upton and you've got Mount Holly. So I'm at the Upton site. So let's go to satellite and continental US. Goes east, all channels. So I'm going to bring up. Please tell me they're not. Why is it figures? Why are there no pictures on here? Don't tell me they're all down. This is so funny. No, okay. So here's the U.S. In action here. Oh, there's a bad frame in there on the end. Okay, that's why. So when we start this, so we're at. You see that dark shade that comes across? That's actually supposed to be, that's usually the sunset. I'm not exactly sure what that is. Why is it like that? It's too early for. Are we no, we are sunset now, right? Okay, so that is the sunset. I'm sorry.
Why is it so
Standard time, save. Hey, James. Standard time, daylight time, that whole battle. But that actually is the sunset moving its way across the planet from east to west.
Why is it so sunny out west?
Well, because it's still not sunset there.
Right, but it looks super sunny.
Oh no, there's a bad frame in there. But if you look at the if you look on the lower left, you can see that feed of clouds. That's coming straight out of the Pacific tropics and shooting northward into the southwest. That's going to be part of that whole system, that developing low that's down there. You've got a lot of tropical moisture shooting northward. Meanwhile, if you look here in the east over us, we've got an upper high that's sitting over us. You see how the clouds are going northwest to southeast? So we're actually in a pretty good spot here. There's a lot of dry air that's sinking southward. So we're in good shape at the moment with all the action in the west. And you'll notice that everything is moving more south to north than it is west to east. So we are fortunately putting together 3 dry days Monday, Tuesday, Wednesday, and probably the daytime Thursday into Thursday night will be dry. So for the first time in quite a while, we've actually got a nice stretch of decent weather, which is a good thing. Now, the other part of this that I want to show you is, where is it? Here, back to this. I wanted to show you the water vapor, because this really, all right, let's see if this has a bad frame in there. We're going to go to the mid-level. These new satellites that they've come up with are terrific. But what this is, ignoring that last frame, and I will just add a whole bunch more frames on this, so we can take it through a longer period of time. But you can actually watch here on the water vapor imagery a storm in the process of developing and what it looks like in the atmosphere. The blue and the yellow, that's all dry air. So when you start to see in the whites and the greenish area, that is all moist air. So if you follow the feed, and we're looking at the middle levels of the atmosphere here, so up at around, say 8 to 13,000 feet, right in that area, you can see the tropical feed of moisture coming in on the lower left from the Pacific across the southern part of Baja through Mexico, and it's streaming all the way up through the Rockies and on up into the northern plains and into Minnesota. Meanwhile, on the other side of that, it kind of turns. You see how it curves over the Great Lakes and then drops southeast? That's all sinking air that's coming to us. And when air is sinking, it's got it's called subsidence. It's all the moisture has been taken out of it. It's the same thing where in the west against the mountains, when winds are coming in off the Pacific and they hit the Sierra Nevadas and the Cascades, that air rises up the side of the mountain. All the moisture is wrung out of it on the west facing side. So when that air comes over the top and then goes down the east side, it's got no moisture left. It's all been wrung out. So when you look at the east side of the mountains, it's bone dry, almost desert-like on the east slopes of the mountains. The west slopes are this, super moist, super snowy. You've got mountain areas out in the west that get hundreds and hundreds of inches of snow a year because of the impacts. Well, that's kind of what's happening here in the east. All the moisture is getting wrung out across the plains, and then it drops down into the east, and we've got this nice dry air. These satellites, by the way, are updated. They got new satellites coming in every 5 minutes. So, and you're able to see all different layers of the atmosphere.
Could the Appalachian Mountains be affecting that like it does out west?
Well, you do have something like that in the east when you get weather systems that tend to be weak. Actually, even the stronger ones, there is a shadow effect in the Appalachians where when we get some of these lows that come out of the Gulf states in cold air, for example, the west facing side gets less and the east-facing sides get more because we get a northeast flow off the ocean that comes into the mountains this way, in the opposite direction of what they do in the west, the low-level winds coming in from the northeast. So you get heavier snows on the east-facing mountains in the Appalachians all the way down in the Carolinas, and then there's a shadow effect on the other side where they get less, quite a bit less. When the storms are coming in from the west, and there's no cold air damming on the east side, then you're going to get most of your precip on the west side of the Appalachians. That's why in the wintertime, when storms go up the west side of the Appalachians, we don't get a lot of snow here down along the coast because we don't have that cold air damming in. The low is too far to the west. It's when they go east of the Appalachians that we get bigger snows. A lot of them went west of the Apps. Yes, that's correct. And that created
Or even if they hug
yeah, or they can go east of the Apps and hug the coast, but you still wind up getting more snow before any changeover. It's a whole different scenario. So the satellite's showing us we've got this really vigorous system, and now we can begin to take a look at how weather models are handling this. So we've got this big storm that is sitting in southeast Colorado, and I've got this is the brand new GFS model, which comes out 4 times a day. So we've got this low that gets wrapped up. The green is rain, the blue is snow, and you'll notice that by the time we get to tomorrow afternoon, we have a very, very deep, intense storm sitting on the Kansas-Colorado border. Whenever you see a lot of those lines, those isobars, those lines of equal pressure, when there's a lot of them, that's a strong storm. The pressure gradient is extremely tight. And what I mean by that is wind is defined by how strong the wind is going to be, is how much pressure change do you have over how much distance, okay? Big pressure change, very, very small distance, big wind, okay? Think back to the wind event we had a couple of weeks ago. That was huge pressure gradient, very, very tight pressure gradient, big pressure change, intense low sitting in the St. Lawrence Valley, strong high pressure sitting in the Dakotas, large change in pressure, relatively small distance, that drives the wind. Hurricanes, for example, the winds in hurricanes are so strong because when you look at the pressure field of the hurricane, you're talking about huge pressure changes over really, really small distances. You're talking about 100 millibars of pressure sometimes over a couple of hundred miles. That is, that's when you start seeing winds of 150, 160, on the bigger ones. In a tornado, which is a very, really small scale cyclone that might only be yards wide, or in some instances they could be, much wider. But their scope is extremely narrow when you think about the fact that they can produce winds in excess of 2 or 250 miles an hour inside those cyclones. you're talking about a really, really super, super tight pressure gradient. I don't even know how, how low the pressure would be measured inside the center of a tornado, but you're talking about really, really super tight pressure gradients. So you have that here in the broad sense with this very deep snow. So with this very deep storm, when I say deep, I mean the pressure is low. So we refer to as when a storm is intensifying, we say it's deepening because the pressure is dropping. It's getting stronger. So we use the word deep as a descriptor of a strengthening storm. And in this case, this is going to produce widespread blizzard conditions all the way up into through Nebraska into South Dakota. And then that storm, by the way, you see all that rain pushes up through Minnesota and Wisconsin. So there's their flooding. Meanwhile, here, we've got this nice high sitting overhead. We're in good shape. And even though this storm gets very intense, it reaches its peak intensity during by tomorrow evening, and then it actually starts to slowly weaken as it moves northeastward, so that by the time it gets here on Friday, it's basically a line of showers that goes by, and that's it. And then after that, we turn cold and dry for the St. Patrick's Day. I've been calling it the St. Patrick's Day holiday weekend because St. Patrick's Day is on a Sunday, so the big parades are on Saturday because you can't have the parades on St. Patrick's Day if St. Patrick's Day is on a Sunday. So it's a 2-day feast, and the 2-day holiday is going to be nice and dry and actually a bit on the cold side. So I'm going to come back to that. Now I want to show you, okay, that's fine and dandy on the surface, but what does that mean when we look upstairs? Because ultimately at the end of the day, weather is driven by what's going on in the upper atmosphere, which is our friend the jet stream. So I'm just going to run this. This is a 16-day loop of what the jet stream looks like. Now I'm going to come back to it, so I'll explain everything. So hang on. So this is how the upper air changes over the next 16 days. Okay, this is the corresponding surface and how it's. By the way, I should say forecast to change. Of course, I, being omnipotent and all powerful, can actually run the atmosphere backwards. Okay, but this is how it looks on the surface. Okay, and that's backwards. And actually, for you young forecasters here, it's actually a good idea to run the maps backwards because you actually get to see where, how it gets to where, how did it get there? I started doing it. I do it because I have the map up and I suddenly discover that I'm on the wrong time frame. So I run it backwards, and I was doing it for a while, and I was like, you know what? I started seeing some things that I didn't actually see it by running it backwards, and I thought it was me. But there's somebody I follow on Twitter who I think is really really good. Okay, cranky weather guy. I don't know if those of you who are, he's on Twitter, and he's very. It's a very. I have a tough time going through his stuff. He he's very technical. I also, by the way, just so you know, in general, as a young forecaster, Ryan, I think I told you, might have said this the last time, but you never look. You always do your stuff first, and then if you afterward, if you start reading stuff. I, as a rule, since the first day I started doing this professionally, I never look at what anyone else is doing until after I've done my forecast. I don't want to be biased by anyone. We all can look at the same things and come up with different conclusions as far as a forecast is concerned, particularly when you're talking about a small, margin of error or a small area of geography. You want to be as unbiased and clean with your thoughts as possible. So the last thing you want to do is to be biased by someone else. So I try not to. I make it a rule. But after I do my forecast stuff, it's not. It's almost impossible not to come up with somebody else's opinions because they're splashed all over the place on social media. So they come front and center. But as long as you're confident in what you're doing, it's important that you're confident in what you're doing and what your forecasting, because you don't want to be suddenly second guessing yourself every time you read something different from someone else, and you start changing everything. Okay, that doesn't work. Okay, you got to make it your own, your own way. So anyway, just kind of digressed away, but I always like the future forecasters that might be, in the room to get into good habits when they're young. Okay, because the fun part of this game is nailing these forecasts and getting them right. So here's our storm. Now again, let's go back to the upper air, and we're going to look at the jet stream and see how that works. So I'm going to take this very wide view, and we're going to look at the jet stream. There we go. I'm going to look at the, over North America, and you can see, a good chunk of the Pacific and the good chunk of the Atlantic. So I've always described the upper air, okay? The higher up you go in the atmosphere, the fewer highs and low H's and L's you're going to see, okay? It's a much smoother place at 18,000 feet. There's, when you look at these weather maps, when they plot these weather maps, they make the assumption that not that the Earth is flat, but that the geography of the Earth is flat. There's no the topography. There are no mountains. There are no there are no valleys. Everything is plotted so that you're looking at a flat surface. So everything is sort of at an even keel. It's also, when you look at these maps, the time that's used is a standard Greenwich Mean Time, or basically the time in London on a 24-hour clock. So when it's midnight Greenwich time, which would be 0Z, you look right up here, you can see 18Z Saturday, that's 2 o'clock in the afternoon, our time. 1800 hours Greenwich time. All over the world, airport observations. This is to have a standard time sequence for when conditions are reported, when weather conditions are reported. It's always, 12 o'clock Greenwich time in New York is 12 o'clock Greenwich time in London. It's 12 o'clock Greenwich time in Tel Aviv. It's 12 o'clock Greenwich time in Beijing, et cetera, et cetera. It gives a standard look. What's that? 12 o'clock, 12Z is now, because we're on daylight saving time, is 8 o'clock. You subtract 4 hours in the morning. So 12Z is 8 o'clock in the morning our time. 18Z, so you have to do 2 conversions, because now it's 12 plus 6, so it's 6 o'clock in the evening in London. You subtract 4, it's 2 o'clock in the afternoon here. Then, of course, when we go to standard time, you subtract 5 hours. And then it would be 7 here, correct? Right. Yeah, it's just annoying. I mean, the whole time concept and the debate with standard time and daylight time, if you ever want to just, it's very interesting, go Google time zones, the history of time zones, and you'll find out some very interesting things about why we have time zones. What's that? Europe does. Florida is actually going to stay on daylight saving time all year round. Massachusetts wants to go to Atlantic Standard Time. Okay, so you'd have to change your clock. Right, you have to change your clock if you're driving up to New Hampshire while you're going through Massachusetts. It's an hour. It's going to be it's just nuts. Okay, so here's the upper air. So here's how the upper air works. Think of I always use this analogy because I certainly remember them. But there was a child's toy, a toddler's toy. It was the old gearbox toy. Okay. Where there were all these different gears. They looked like gears, and it was a puzzle. They put the gears in the box. There was a handle on one of the gears. Once they got all the gears in the box, the kid would turn a handle, and all the gears would turn. And the kid would be happy. You kept them occupied for about 10 minutes. You pretended like you could actually get something done while you had the kid occupied, and then he would start crying again and take the whole puzzle apart. But the bottom line is, the gears are turning, and one gear turns the other. And this is how the upper atmosphere works, with one notable difference, and that is that the gears are not fixed in magnitude. They are constantly changing in size and in shape, and they're moving around, okay? So as each one gear changes in size and shape and moves around, it impacts the other gears that are changing in size and shape and are moving around. So as we watch the gears, the we're looking at roughly eight. This is the 500 millibar. So roughly 18,000 feet. So what these maps do is the lines that you are drawing. These are like the isobars, the lines of equal pressure, except in the upper air we draw lines of equal height. All right. Each what the map represents is how high in the atmosphere do you go. If I had a home barometer in my hand, okay, and it measures in millibars, I'm going to go up in the atmosphere, higher and higher. I want to get to the point where that barometer is going to read a pressure of 500 millibars. Okay, when I reach that point, I write the height down of how many meters above the ground did I get to that pressure, and then I play connect the dots, and it gives you a basically flat standard view of the pressure. It compensates for altitude, mountains, valleys, and all the rest of it. So you get this sort of very flat look by doing it that way.
Is that what the numbers are?
Right. So each one of these numbers, for example, add a 0, 585 means that at this particular point, if you want to get a pressure of 500 millibars, you have to go up 5,850 meters in the atmosphere to get there. Okay. Now you go up to the north where you see the blue and you've got the number 537. It's 5,370 meters. So you don't have to go up as high to get that pressure because the air, as you go further north, is generally colder. It's more dense, it's heavier, so your pressures you're going to achieve that pressure at a lower altitude. Because remember, the pressure at the ground is where, is very high. You start to go up, the pressures drop. But if you've got colder air that's dense, it's going to bring that height down a little bit. Now, the difference between 5850 and, well, let's round it off, and 5,350 meters, 5,850 meters is 500 meters. It's 1,500 feet. Okay, that's not a big deal, overall when you talk about the whole scope of the atmosphere. So it's a fairly, even though it's not actually smooth, it's kind of tilted because you're higher here and you're slightly lower here, but it's all basically the same pressure level. So remember the fact that winds blow counterclockwise around lows and clockwise around highs. So these blue circles here, those are all low pressures in the upper levels of the atmosphere. And you don't really have any big highs this time of year. You've got one south of the Azores. If you go on the upper right, that's an upper air high over there. So the wind is clockwise around that, blowing clockwise around that high in the upper levels. So I'm going to now start moving the gears here by running through this weather model and stopping at this. This was last night. There's actually an upper high sitting in the Gulf of Mexico that pops up. And now you can see how the gears are playing out in the west. You got this very deep trough in the west. The winds along the west coast in the upper atmosphere, remember, counterclockwise around lows. So you've got winds blowing from the north, south into the southwest, and then they turn up straight north into the northern plains. Here, we've got this, nice little ridge protecting us. Now, over time, what's going to happen? Well, that system starts to come out. But I'm going to stop for a second. Look at the gear that is coming into, go on the far left. This is going to possibly give us our one last winter gasp of snow. Okay. On the far left, you guys can see where the Hawaiian Islands are. Okay. You're going to see this deep trough drop down toward Hawaii. So look. So now what happens here in the east? Suddenly, we go from having this big upper high, which is basically a warmer atmospheric profile, to suddenly, as we go through the weekend, we suddenly now have a trough here in the east. And right here near the Great Lakes is a shortwave trough that's coming down for Sunday night into Monday morning, or later Sunday night during the day on Monday, that swings toward the coast. The gear out here in the Pacific and the big storm in the plains orchestrate this temporary pattern change. And suddenly you have a cold flow coming into the eastern part of the United States, and now we've got this system swinging into the east. Now, I'm going to run this out over time. So now we are a week from now, okay? The eastern system is lifting out. If you follow the lines along, you can make the assumption that if I follow this line along, and you assume that line stays like that for a couple of days, that the air that's out here, okay, is going to take the track, down, up, and toward the southeast coast. If you look at the lines that are up in Canada and you follow them down, they come into the northeast. So our air a week from now should be coming more from Canada than it would be from the Pacific origin. If it was coming in from the Pacific, it would be warm. If it was coming down from the north, it would be cold. And we seem to stay in this trough position through much of next week, and then it pulls out. And you'll notice that gear that's out here near the Hawaiian Islands starts to move away, and that trough starts to move away. So this is what I'm saying as far as the changing gears and how the impact of one has on the other. And suddenly now, as we head toward the last days of March, now look where our air is coming from, according to this model anyway. We're getting this warmer flow from Texas, from Mexico, on up into the Ohio Valley and into the Northeast. So this would suggest, the way the models are suggesting that what's going on in the atmosphere, that we're going to get through this week. Friday, we're going to get whatever showers we get. Then we're going to turn colder over the weekend and probably stay cold for a good chunk of next week. And then the pattern's going to change again to a warmer pattern. We almost go back to what we have now: big upper high in the east, trough out in the west. So I think that this is what we're seeing for the next week. This temporary change makes a lot of sense in terms of what's going on overall with the atmosphere. I think that for the first time in a number of years, we're actually going to see spring weather coming reasonably on time. Now, when I say spring weather, I know that conjures up Disney images of Bambi and flowers blooming in the forest and all the rest of it. Spring in this area in the Northeast is and always will be a non-existent season as far as I'm concerned. It is a season where switches get flipped. You suddenly go from very cold to very hot, okay? And that usually happens sometime in mid-May. It's not this sort of gentle, every day is a degree or two warmer and every day is sunshine. It's a miserable time of year. We have a 40-degree ocean with a marine layer that comes in on an almost regular basis. It's a time of year where it can be in the 70s in central and south Jersey, away from the ocean. And if you're on the shore, or if you're or from New York City east on Long Island, where I am, I'm in the 40s with low clouds and fog. Well, you people are sitting here in the low to mid 80s. I've seen it where it's been in the low to mid 80s here, and I'm sitting in like mid 40s with a screaming northeast wind. Okay, it's not a fun time of year. It's just not. There's the cold ocean prevents it. The further west you are, the less impact the ocean has, so you do get more of the nicer days and the longer stretches. But if you're right along the shore, you're or within reasonable proximity of the shore, you're always going to have that marine layer issue during the springtime until the ocean water temperatures get into the 60s, and that doesn't happen until maybe mid to late June at the earliest. Yeah, because you're on the other side of that. Your water temperatures are at their highs, so you don't have that marine influence. So let's look at the last major snowstorm that will be telegraphed all over Facebook, because everything has to be the apocalypse. All right, so I am going to go to this very tight view Actually, not so tight. Let me get a little wider.
Because
everything has to be the apocalypse. No, I know. All right, so I am going to go to this very tight view. Actually, not so tight. Let me get well, I would venture to say that all models are horrible. But the problem is that the problem is that they're not that they're used as absolutes, and that's not what they're intended to be. So here's what's happening on a tight view. So here's our little front for Friday. It goes by. We get some showers. It gets cold. You'll notice that there's some, blue snows that you see in northwest Pennsylvania and up through upstate New York. That's all lake effect stuff. Storm chasers, future storm chasers here. Put it on your list that you want to go. And it's a little hard to time, but at least it's closer. But you really want to see lake effect coming off Lake Ontario on the east shores of Lake Ontario. If you're into thunder snow, that's where you have to go. I have friends that live up north of Syracuse in Pulaski and on up toward Watertown, and I've seen pictures of lake effect snows that come in with thunderstorms going on at the same time. They are the most outrageous things you have ever seen. Lightning shows like you have never seen anywhere. They beat the ones even in Florida. So anyway, that's my recommendation if you want a storm chase. So we go through the weekend. St. Patrick's Day weekend looks pretty quiet. There's not much going on, but if you notice up near the Great Lakes, there's a little weak system there with some little light blue snows around the Great Lakes that drops southeastward, and that's what is probably going to be advertised all over Facebook as the all-time March burying snowstorm ever to occur. Okay, that little low. All right, it's right. It's kind of a microcosm of the whole winter that it should go out this way. It's a very weak clipper system. If you look at it from the standpoint of the upper air, you can actually pick it out. But this is what it looks like in the upper atmosphere. Here's our cold front for Friday, and here's the upper air system swinging down from the Great Lakes for Sunday. When we look at when I show you that system in the west, when you see an upper air, when in the upper air, when we're going to get a big storm, okay, I'm just backing this up to this particular system. When your upper air looks like this in the east, okay, that's a big storm. Okay, when the upper air looks like what I just showed you before this map, that is not a big storm. So you know what? At this point, why don't we look back at a big storm? First of all, let's go back to a year ago, because as you remember last year, we had the yes, as I call them, the four nor'easters of the apocalypse. That was a very remarkable look. That was a remarkable time, and I don't expect to see that like that again. There are certain once in a lifetime events that you see weather-wise, and I think the four nor'easters in 2.5 weeks, that's going to be a hard repeat to pull. A Hurricane Sandy is a generational event. The blizzard of '96, the Boxing Day snowstorm, those are all generational events. When they happen, they're like when you get a speeding ticket. God help if you don't. But when you get a speeding ticket, when you haven't gotten one in many, many years, you suddenly, for at least a while, feel like you're very, very conscious of how fast you're driving. So you think, I just got one, I'm going to get another. Okay, until a little time passes by and you go and you relax. And well, April of '82, again, those are generational events. So you see them once every 25 years. It's just that when they 20 or 25 years, it's just that when they happen, you think they're going to happen all the time. So here's the I just kind of picked a random date. I just went back to a year ago. I want to see what it takes us to. Here's the beginning of it. Let me just move the map over. So here's what This is one of the four nor'easters. I think this might have been the third one, but you've got low pressure in western North Carolina. You've got a second low that's developing off the North Carolina coast, and that starts to strengthen and move northward, and it gets very intense here as it's sitting off the Virginia coast. Each one of those nor'easters, now it's down to a 9.7. This storm here, this nor'easter that occurred on the 13th of March, which is tomorrow of last year, was the each one of those nor'easters wound up being they all were very, very strong. This one is as strong as the Great Plains storm that we're looking at for tonight and tomorrow in the Great Plains in terms of pressure and in terms of magnitude and its impact on the upper atmosphere. But we got hammered in inland areas from this one. I think there were some 20 and 30-inch snow amounts that were recorded. And then in the last one, the fourth one, that's when I had my house anyway. I can remember all day long and driving in to go to work because it was snowing, but it was during the day. And when it snows in March during the day, with borderline temperatures, if it's not snowing very hard, it's not going to stick to roadways. And even on the colder surfaces, a lot of it's going to melt because of the increasing sun angle, the infrared rays, and so on. So I heard it. I started hearing it all the way in, and then messages on social media. It's a bust. It's a bust. It's a bust. It's a bust. And then at about 9 o'clock, 9:30 at night on Long Island, I suddenly started seeing the message, it's puking snow. And it was snowing in the snow globe, what I call snow globe snow, which is 5 inches an hour for about 3 hours. If you've never experienced that, it's like it's really, yeah, for a snow lover it's pure heaven, but it's also very surreal because I remember in the for Long Island we call it the Snowmageddon storm of 2013 because we snowed 5 inches an hour for almost 5 hours. I finished up with a little over 30. It was the most I've ever seen, in my time out there from one storm. But while it was going on, it's kind of weird, to go out with your snowblower once an hour and blow out like 5 inches of snow. No, but you can't because it was so high that it went above. I mean, but just the idea that you could, a 5 to 6 inch snowstorm is an average snowfall here on a bigger storm. So you're doing it 6 times. And every hour you're going out and like what you just got rid of is now there again. Okay? And then the walls on either side are higher. So you're trying to blow this stuff away. No, it was a very surreal thing. And you're standing out while it's snowing. And I could, my hand is here. I could barely see beyond it. It was so hard. Well, yeah, that's why I said for a storm chaser, you really need to make a point to go to places like Pulaski and Mexico, New York, and on up toward Watertown, Redfield. You just make sure that whatever hotel you stay at has at least a second floor. Okay, because you don't want to be on a first floor. So we'll go back to the '93 storm, and then we'll start with questions because I know you guys got questions. Usually with these talks that wind up going into the parking lot, and the police have to come and break the weather people apart because we're like a gang or something. You know how vicious we can be. All right, so this is the '93 superstorm. Okay, so that pressure that you saw, all right, off the East Coast with the nor'easter, and that pressure that you saw for the Great Plains storm, which was a 970 something millibar low, that is the pressure that you're finding on the Florida Panhandle. To put it in perspective, the only time pressures ever get that low in the Florida Panhandle was during a hurricane. This was one of the most intense storms ever observed that far south on a surface map. You never see this. Okay, again, a generational event, and it just moved its way northward, just inland of the coast, all the way up through interior North Carolina. I mean, they had 1 foot plus snows all the way down into central and southern Georgia out of this. Okay, now you've got a pressure of 960. Okay, in southeastern Virginia, that's a borderline Category 3 hurricane pressure, or can be. All right, we had snow that went over to rain from east to west, but I got almost a foot of snow where I live in central Long Island before the changeover happened. But this was a generational storm, tracked, just kind of straddled the immediate coastline as it moved up to the northeast. 30 and 40-inch snow amounts in upstate New York, and on up into Saratoga. You'll never see you know I don't know. It'll happen again someday, but I don't know when that'll be. But as I said, when these big mega events happen, you feel very vulnerable with regards to all of this.
For some reason, there hasn't really been any rain to snow events. They've all been the opposite. Snow to rain.
Go back to the winter of 2005, 2006. They were all rain to snow events, which actually is those are my favorite kind of storms, because for snow lovers, when it's raining, right, exactly. You watch. You're looking. If you're driving, you're looking at the windshield, and you look. The raindrop hits, and you see these like little pin drops, and you think it's the gloppy flakes, and then the drops start making noise, and then you're starting to see the changeover. Actually, for me, that's always been the rain changing to heavy snow is you go from ultimate depression to ultimate ecstasy very fast. There's a weather forum website. I think they have the best name. It's called 33 in Rain, because that's the most depressing weather observation a snow lover could ever see, is 33 in Rain. All right, so we could go. There's so much that we can do weather-wise. It would take multiple talks to do it. So I'm going to open this up to questions. Let me just do really quick shameless self-promotion. So you can watch me on FiOS One News if you have FiOS as your TV source, but you don't need television. You can watch me on my YouTube channel, which everybody is doing right now, those that are subscribed to it. And my YouTube channel is Joe Chaffee. I do live streams usually once a day, and they usually are at about 7 or 7:30 at night. And of course, you could always watch them on the replay. I'm on Facebook at Meteorologist Joe Chaffee. I am on Twitter at Joe Chaffee. It's JoeCioffi, although I don't spend a whole lot of time on Twitter. I have 3 websites: meteorologistjoechaffee.com, nycweathernow.com, that my buddy Ben Scott, or as he goes by the caricature Angry Ben. I'm Joe Stradamus, he's Angry Ben. And Angry Ben will be coming out with a weather app soon. I'm working on that. So you can download my free weather app on Google Play or on the App Store. It's you can just search Meteorologist Joe Chaffee. It should come up. On Android, you can search Joe Chaffee and it'll come up. But Apple wanted to make my life complicated. And for those of you who are really interested in getting a really supercharged weather experience, I do have a subscription platform on Patreon. It's patreon.com/meteorologist Joe Chaffee, but you can find links to that all over the place as well. It's just $2 a month. I do extra posts just for members. I do live streams just for members only. And you can message me at any time for a quick response. And if you're in the snow removal business, you can come talk to me anytime. I have a number of you guys on, and I am your forecaster, your friend, and your therapist. Okay? And they all go together. I have a lot of fun with the snow removal guys. You guys are great. You do, you're out there in the thick of it, and it's, and I can understand the frustration that, with respect to getting the right kind of information. But if you would just forecast shop a little bit less, you'd make your life a lot easier. Right? Okay, so Scott, you want to go back to your earlier question with regards to the snow maps?
Well, but I wanted to ask you a question. You once said on, I think, a live stream or Patreon that, you know, the only snowstorm that you thought you could predict 5 days or more in advance was, I think, the '96 storm, correct?
The '96 blizzard was actually very well telegraphed by models and and I thought pretty well predicted. The minor details had to be, you can never do the minor details. You always have to, well, I say minor details in terms of like specific snow amounts. You really have to get inside 72 hours to give a pretty decent early look. But the '96 storm actually, and also the '93 storm, were handled very well by models. And in those days, we didn't have, now we have models that go out, 16 days. You've got the European actually goes out 45 days. It's got all kinds of silly nonsense on it. But at the time, it was only going out, it had just gone out from 7 days to 10 days. So we were just learning to experience the 10-day, the extension out to the 10-day. Plus, there were fewer models available. But the ones that were there handled it very, very well. I'm a firm believer, by the way, that as in the interest of making models better, they've been cramming more and more data into them. And I think what that's done is actually made them worse. What's that?
If they can't handle enough data, it could confuse the models.
Or, data that, I mean, I'm not really too familiar on, yeah, but I'm not too familiar on how they write. They write these long mathematical equations. It's all above my, it's way above my pay grade, and my, where my head is at. But, it seems to me sometimes if you put too much, if you put too many groceries in a bag, what happens? The bag rips. Okay. So I'm wondering whether, if they're putting too much, they're putting too much data. Maybe some of the data is throwing off other data around. I don't know. I do know that, they've been trying. They had this upgrade for the GFS model. It's been running side by side, so they call it the parallel GFS. But it's been pretty bad. It's behaving more like the perpendicular GFS. So they decided not to bring it and make it operational. They pulled it back, and they're going to wait to bring it operational so they can figure out what's wrong with it. Because apparently it was too cold, too snowy, too a lot of things. So because the spacing. Okay, so there's three. The NAM models. There's three different versions of it. There's a 32-kilometer version, a 12-kilometer version, and a 3-kilometer version. The kilometers are, so picture a grid, okay? Picture a grid, and on each point of the grid, there's data that's collected that goes into the model. So you've got the 32-kilometer, then you've got the 12-kilometer, so you get more data in, smaller grid. The 3-kilometer is super small, all right? So the 3-kilometer NAM is really supposed to be good for really small scale weather events like thunderstorms, severe weather and that kind of thing. The 12-kilometer one was an improvement from the old 32. So now they got the 12. I don't even know why they still run the 32. It might be. It might be. So the 12, yeah. So the 12-kilometer is good for, broad scale wintertime events, general overrunning rain events that doesn't have a lot of convection in it, just kind of a straight cloudy, rainy, no thunderstorm type of scenario. So you brought up the question about, I'm sorry, what was I kind of lost my way. Oh, okay. So let's address. I want to address the snow maps because this is really important for you, for those of you that are really involved with weather and with respect to snow. I have there's on my YouTube channel. I have a section for instructional videos. It's a short it's a lot shorter than this talk, I promise. There's a 6 or 7 minute video I did on snow maps, and let me show you what those snow maps are and why you should not use them. Okay.
There's a 6 or 7 minute video.
Okay, so
on snow maps, and let me show you what those.
the reason why they have the snow forecast maps, and they have them for all the models. All right, um, uh, they are, it's basically a marketplace in a sense. If there's demand, they'll create supply. Here is this is actually this is the European model, which you can't see publicly. This is a subscription site. What's that? Well, this is what at 156 hours the radar is supposed to look like, at least according to the European. This is Monday going into Monday evening. So this is the system for Sunday night, Monday on the European. So it's got this snow area that goes out. Now that's the precip type. Okay, so it's got all of New Jersey and snow here for Monday during the day. In terms of total snowfall, so what this does is it basically takes the rainfall that the model's predicting. It applies a ratio of 10 to 1. So in other words, 1 inch of rain equals 10 inches of snow on most of the maps. And then it just plots out what it thinks the snowfall is going to be. So from all of that snowing all day on Monday, the European model is predicting 1.4 inches for New York City, 2/10 of an inch at Philadelphia, half an inch at Scranton. And you can see there's this narrow, now we know this is a weak system, clearly. But you can see there's a little strap of guarantee you when this model runs again overnight, it's going to look different, okay? And this is one reason why you don't use snow.
I'm gonna have to pull up the West Coast.
Now, when you look at these snow maps, you got to be careful for a couple of things. First of all, when you're pulling them up from these sites, they can be cumulative, okay? So if you're looking at a map at day 10, that's 10 days of snowfall. So make sure that you know how many events are in those 10 days. I can't tell you how many times I've seen maps put up showing, and this happened actually during the month of February, and this brings up another point, by the way. In terms of what the weather models, I know that in the weather world, the European is regarded as, was regarded by some people, and unfortunately, this is not the way you're supposed to approach forecasting weather, with a certain amount of reverence that you might, leave to the Pope, this sort of infallible, model. And I would point out that the European this year should be congratulated, the European model, because not a single one of its snowstorms that it predicted for the East Coast came to be. Okay, not a single one. There are at least 6 or 7 that come to mind in the long range that model showed 1 foot plus snowstorms and even 2 foot plus snowstorms that were just beyond ridiculous, didn't match the overall weather pattern that we were in. And unfortunately, this stuff gets out there. I say unfortunately for me, only because of the fact that it just makes extra work for me. And then I get one of my favorite things is I get these messages. I'm hearing in chatter room. I'm hearing that there's a snowstorm for this day, and I keep thinking, like, do you guys sit around in bars drinking beers and literally gossiping about weather? I mean, seriously, but they make it sound like it's a secret piece of information. I'm hearing that there might be something on such and such a day. No, you're clicking on something that you shouldn't be clicking on because you're not getting what it's supposed to mean. But seriously, you got to be really careful. Some of these maps, when they're out there, they could be cumulative over 10 days. They may show multiple events. They also don't take into account sleet or freezing rain, and particularly when it comes to sleet, because the ratio for sleet is about 3 to 1 versus 10 to 1. So we had the instance from this weekend, okay, from what we happened this weekend with the early start, the snow that changed over to sleet and then went over to rain. We had weather models showing for much of New Jersey, half a foot to a foot. of total, quote, snowfall. And it was wrong, clearly, because these maps don't always take into account sleet or freezing rain or melting or time of year or the dreaded sun angle, depending on, where you are, in the month of March or going into April. So you got to be very, very careful and, and be suspect. If it's put up and it's more than three days in advance, be very, very, be skeptical, and then make sure you're seeing it. What source are you seeing it? Who's telling you the information? I have this is how I do things. So when there's an impending, let's say I see something on the long range that bears potential, okay, I'll write about it, but I'll write about it in the context of what's going on in the upper air. What would support the idea of a snow event happening? What's working against it? Does it have, where's the potential lie in all of this? I don't really throw out numbers at all. I let everybody else throw the numbers out. Because you know what? If I put down, whatever I put down is going to get misquoted anyway. If I put down that this, it's a 3-inch or less event, it becomes a 3 feet or less event. So I just kind of talk about things in the broad sense. And I'm very honest about the meteorology that I write about. I mean, if I see that something has potential to be a problem, I'm going to say it. If I see that something does not have the potential to be a problem, I'm going to say it. I was accused, I thought this was so funny because it was in the other direction. All through this period from late February and through March, I've been really skeptical of given the way the winter has been, the idea that this March was going to be anything like last year was completely off the table. Okay, you had a lot of people pushing that angle. There was nothing that remotely suggested that. We've got 2 moderate to light events. What we had, the last couple of weeks. Really in the scope of things, what were they? They were decent snowfalls. They were half-a-foot events, but they weren't anything that stood out. They weren't crippling by any stretch of the imagination. So, my argument was that this was not going to be a winter that was going to produce, a snowstorm of importance this late in the season. Last year, you had everything there on the table 2 weeks before of what we were going into, and I wrote openly about it, and was challenged, accused of hype, all this other stuff. Not that I ever even got specific. I had actually somebody challenge me the other way, which I thought was hilarious, accusing me of having an agenda for not wanting it to snow. And I thought, now I thought about this. Now, when it comes to like snow lovers, okay, I'm with the best of the snow lovers that are here. I'm as much a snow lover as anyone else. But I am not going to forecast, I am not going to wish cast my career. I'm going to forecast my career, okay? So I am going to forecast what I think is going to happen, and not what I would love to have. That's something that I've carried through all the time. There are people out there who wish cast. But I actually got accused of having an agenda for it not wanting to snow, and I just started thinking about it. I was like, what would that be? I mean, I don't understand. I'm not a snow hater, so I'm not sure what agenda I would have to drive people away from my websites, to drive people away from my Facebook page. But it just shows you the passion that some people have over crystallized water. When you think about it, it's crystallized water, and they get angry, and they get it's crystallized water. Yeah. So what I do is when I get to 72 hours of an event, I will put out an early call snow forecast map that will be up, that the weather folks will read, everybody else will not, will look at. I love putting up a map of New Jersey, for example, and then being asked by somebody, how much am I going to get for my zip code? There's a map. You're on a map. If you're on a weather site, you need to kind of know how to read a map. But it's amazing to me that that you don't get. It's like, but it also falls into the category of, I know you're telling everybody 3 to 6 on your map, but I know that that's not the real forecast. What's the real forecast? You can tell me. I won't tell anybody. You know, I want to get to the store before everybody else and make sure I get the last loaf of bread and the last egg. You know, but it's just again, the passion is just amazing. So the bottom line is, look, well, be careful of snowmen. I do an early call, 72 hours out. For those of you who follow me on a regular basis, know that I do not change my maps. My snow forecast map gets usually one change, okay? When we're about 24 hours to 36 hours before start time, when I feel confident in myself and my forecast, I'll make a final call. That's what it is. And then after that, I forecast on the fly. So if I need to, if it becomes evident that I under forecasted, I'll nudge up. If I over forecast it, I'll nudge down. I was actually particularly happy with myself this year. Just a little, self-praise. But my early calls worked out pretty good on a lot of the events we had. I was very happy with that because, well, they were pretty good. They weren't perfect, but they were pretty good. And I did something with the last event. Yeah, the last snow event from last weekend. I did a secret early call map for my snow guys, my snow removal guys. Well, I did the early call a day and a half, like almost 4.5 days out. All right, which I've never done. So I did it 4.5 days out, and then I let it out the same map. I didn't change it at all. Let it out for like I would normally do for everybody to see. And then when I made the final call, the only thing I changed, I didn't change my boundaries. I just added a stripe of 6-inch plus, and I was very happy because a small bust on Long Island, but everybody else came out pretty close. And that makes, in a game where every time you forecast, you're going, one of the things about snow forecasting is especially if you're doing it over a large geography, you're always going to bust for somebody. It is absolutely impossible to get it exactly. You can, as smooth as a map you can make. You can't account for every hill, every mountain, every valley, a wind direction of east versus east northeast. All these things have local impacts and microclimates that it's just I can't. It's impossible to do that. So. Yes. No. Look, if I have to change, if I have to forecast on the fly, absolutely. But you have to do that. Yeah. No, well, listen, your observations are so incredibly useful because you plug up holes and expose microclimates that years ago we really didn't know existed. When I moved out to Long Island, before the Weather Service moved out to Long Island, and living out there where I am, I discovered that, well, I didn't personally discover it, but just observed it. The people who did the research then realized that there's actually a snow belt in Long Island, and I live in that snow belt. That's on it's in Suffolk County, and extends from near not too far from the county line, all the way east to about Riverhead. There is, people seem to think that if you have never been out there, there's this idea that Long Island, for some reason, everybody seems to think it's flat. It's not. We have areas on Long Island that have elevation that go up to almost 500 feet. I actually live within 3 miles of the highest, above sea level. But there's Long Island sound effects from a northeast wind that impact where I live that make the annual snowfall 5 to 7 inches higher than it is south of me. There is a snow effect.
You're also far enough from the Atlantic.
I'm 2 miles from MacArthur Airport. 2 miles. Okay. So in the Snowmageddon storm of February 2013, that I got over 30 inches. MacArthur, 2 miles from me, got less than 20. There was a 10-inch difference over 2 miles. Okay. And my amount, the amount that I measured was verified by everybody that was around me, local weather observers around me that got actually even higher amounts. So there's a huge difference because just south of me, so I'm on there's a hill there's a spine that goes up. I'm on this side, the north side of the spine. South of the spine, it's all flat, all the way down to the beach. I can snow for. I have seen it snow for as long as 2 hours to get the 2 miles from MacArthur to my house, depending on the wind. It doesn't. It takes a while for it to come over that ridge. And in the Snowmageddon storm, for about 6 hours, I was driving from my house up 1 mile up the hill to the other side of the hill. It was literally a wall of white right at the top of that hill. So I would drive out of it into rain, drove down toward the South Shore, did what I had to do, come back up. The white wall was still there, went up the hill, through the white wall, underneath the other side, and I'm like heavy snow. 2 miles, But there's all these microclimates that you guys all fill in. So when there's something going on, when there's a snowstorm going on, there are going to be snow events where we literally have to forecast, you're forecasting what's going on. There are times when what models are forecasting and what's on the radar are two different things. Okay. The experienced forecaster is going to stop looking at the models and look at the radar and look at the odds. I don't look very much when we're inside 24 hours and we're about to start. I don't look at the models anymore. I don't even look at the short range models anymore. It's all radar. It's all obs. I look for on the observations. I look at the observations. I look for 1/4 mile S plus or heavy snow. Now the new way they write on the METAR, but I look for that. I look for snow increase. 2 inches in the last hour, 5 on the ground. That's what matters.
As an observer, you can tell when the storm starts. If they're forecasting like a heavier snow, but all of a sudden you're just getting like small flakes and it's coming moderate and it doesn't seem to be getting there. Something's going on in the atmosphere and it's just not going to get it.
Yeah, I kind of sat. Well, where I was at last Sunday night's thing, I got 3. I got 3.5 inches at my house. About 5 miles north of me, they had about 5 plus. About 5 miles south of me, they had about an inch or less. I literally, the radar started shifting the heavy snow just north of the North Shore of Long Island into Connecticut, and I could see that. Yeah, I could see that band. So I went over to sleep for a while, and even a little bit of freezing rain. It's but the observing part of it is something that is not done enough by a lot of folks.
And I think they're getting better at it if you look at it.
Yeah,
compared to years ago.
Or maybe they're at least taking the bad ones out.
Well, I don't know if
Making
they're
it
doing
public.
that.
You weren't there for the Lindsay Storm.
Yeah, that's possible.
Oh, I have a story. Well, but I was around for the Lindsay Storm. I wasn't working. I tell you a story about the Lindsay Storm with me. So, what's that? Yes, but I lived in the Bronx at the time. Okay, in the Lindsay snowstorm, and in the Lindsay snowstorm, you would appreciate this story. I don't know for those of you who are familiar with the Bronx or not. There was an amusement park in the East Bronx called Freedom Land, and Freedom Land went away because the land became too valuable, and they built Co-op City, and it was in the process of being constructed. I lived about a 2-mile walk from Co-op City. Maybe it was a little less than that. Maybe it was about a mile and a half. It's not like going to school and walking 10 miles each way with no shoes. Okay, but what happened was my brother was at the time was 23 months. We had and my sister was 4. It was 5. I was 10. We had no milk in the house. Okay, for the snowstorm. Okay, we had no milk in the house, and actually, where we lived in the Bronx, there were no. You had to go. You had to go a good 3/4 of a mile in any direction to find a store. Okay, now remember, this was at a time where, maybe only one person drove, all right? Now, roads weren't cleared because it was the Lindsay snowstorm, so they were all in Florida on vacation or wherever they were. And it was a surprise because it wasn't forecasted very well. So my mother needed milk. So I wound up with the chore of walking to Co-op City, and there's 2 feet of snow on the ground. I remember, it was in the 20s, and there was a fierce, 30, 40 mile an hour wind. So I got to the New England Thruway. There's an overpass there. Cars were abandoned. Okay, there was 3, 4 feet of snow, drifts and everything. I walked over the overpass. I come down the other side. Now here's Co-op City. It's all these buildings are under construction. Some of them were complete. There was an open supermarket there. When I got down to the bottom of that uh, uh, overpass, it was just a walkway. So you come down. What I couldn't see was that in the construction, they had dug a 6 foot by 6 foot rectangular ditch that went down 3 feet. Okay, and well, more than 3 feet. I came off the overpass and I took a step and went right down. I could not get out. Okay, I couldn't climb out. I was in snow up to here. I couldn't pull myself up, and I'm grabbing onto nothing because it's just snow you can grab on. I was in there for probably about 20 minutes. Seemed like longer. And then someone happened to come along because there wasn't anybody outside. Someone happened to come along and pull me out. True story. I could have died in that storm. Have a little sympathy for me, please. This should have brought you to tears. Where were you? You could have helped me. You didn't bring any milk home, right?
So did you ever get the milk home?
I actually did. I got the milk home. Well, it was as the.
At least the store wasn't closed.
What's that?
At least the store wasn't closed.
Thankfully, actually, the guy who pulled me out happened to be a worker there, and he drove me back. He drove me back to my house in the truck. Was able to cut through the drifts. It was kindness of strangers. It was a memorable moment for me that sticks out in my head. Interacting with weather.
12 inches of snow. I kept hearing about the Lindsay Storm. Well, I had a lady friend that lived near Freeport. I used to go out there every Wednesday.
Sticks out in my head.
Snowed Saturday night to Sunday. And I'm driving, and when I get near Kennedy Airport, there's one lane open with plow about 4 or 5 feet high.
Yeah.
And only one lane. And I couldn't believe it.
Oh yeah, that storm was, remember that was at a time. It's not like today, where, as I said from the beginning, we're going to have to be standing outside catching every flake, because it will be, just politically and wrong for a single snowflake to actually hit the ground, because God forbid, we should be delayed. But yeah, that was a day where they did the best they could, and there was much more tolerance, I think, for the imperfections of getting street plowed versus not getting street plowed. Although the folks in Queens will argue about having to wait 3 weeks to get their streets cleaned. Yes, that was a horror for Queens. Yeah, that was a day where. Well, it cost Lindsay his re-election. Yep. Yes, sir.
The Lindsay Storm also, the only storm I can remember, literally in the Bronx, walked on car. You didn't see any.
Yeah, you couldn't see anything. I remember. That's how, when you got to the Thruway, that's how it was.
That's the only storm that I've seen in my lifetime that did that. My father said 40.
Yeah, the 96 and the 47 storm. Yeah, on Long Island, the blizzard of 78. We got to wrap it up. Oh, you have a question? Okay. You let me know, Janet, when it's time.
Close at 9, so we have time to.
Okay. Brian, hang on 1 second, okay? Go ahead. Yeah, the 96 and the 47 storm. Yeah, the nine and on Long Island the blizzard of 78. We got to wrap it up. Okay, so oh, you have a question? Okay, you let me know, Janet, when it's time. All right, so here's how I would answer this. Okay, well, let me just tell you in terms of my observations and from what I've seen. I'm not a climatologist, okay, which you know, climatologists have an advantage because they get to look at they're going to get to look at piles of numbers going back decades and decades and even longer. Okay, which is kind of how you have to look at the overall scale of climate. It's a long-term thing. It's not a short-term thing. So there is, unfortunately, it's been, as we know, it's been politicized. It's politicized to the nth degree. There's a lot here that's going on. Okay, some of it is, has to do with science. But some of it also has to do with politics and money and moving, money from A to B. I don't want to get into the moving money from A to B because money's a touchy subject and everybody gets their back up. So this is how this is what I would say. I think it's kind of. I think we all have to recognize the fact that whatever it is we do with respect to the environment, we have impact. Okay, when you walk in a park and you're walking, or in a forest and you're walking with your boots on, you're leaving a trail of impact on hitting the ground. That hitting the ground impacts maybe how an ant colony builds its anthill, or how a bird gathers its food. I mean, every act you do has some kind of chain reaction going down the road. So when we're doing things that are environmentally negative, it's going to have some impact, even if it's a small one. And conversely, when we do environmentally things that are positive, it's going to do positive things. Now, with that understood, I would just say this. From what I have noticed in the last, for example, in the last 20 years, there has been a decided increase in the number of snowstorms that we have experienced here in the wintertime. In terms of their production, we've seen more snowstorms in this general area that have produced 20 inches or more in snowfall in the last 20 years than probably in the last 80 or 90 years before that. And certainly from the prior 30-year period from 1970 to 2000, which was one of the least snowiest periods on record for this area. Now we're having one of our snowiest periods on record to kind of compensate the other. So is it secular or is it cyclical? That's the question. And unfortunately, none of us are going to live long enough to know whether it's a secular change. When I say a secular change, I mean a change going, over many hundreds of years. All right. Or if it's just a cyclical change. There are always these ups. Weather is seldom like this. Okay. It's always like this. It's up here, down here, up here, down here. It's a world of extremes that when you average it out, comes out to what's called normal. I find that people's memories are skewed in a big way. We tend to gravitate to those things that make us happy when we think back about the past. I've always asked this question. I didn't do it with the folks today, but one of the questions I always ask, and I love the answer I get because it's always the same. I ask people the question: did it snow more? I'm 60 years old, so did it snow more and I give them the period, 1970 to 2000, or has it snowed more from 2000 to 2019 on average? And I look at I ask people to go back into their youth. Did it snow more when they're younger than they now? And inevitably, everybody says that it snowed more when they were young. The snow used to be up over our heads, they would say, because they were shorter. Okay, but again, it's perception. So, you get these news stories, and some of them borderline ridiculous. You get these news stories that act as if it's never snowed before. Or a wonderful example, when I mentioned before about the world rotating around the axis of the I-95 corridor from Boston to Washington, there was an article in the New York Times. Now, this is a rehash article that I have seen on and off for the last 20 or so years. The end times for snowfall, pointing to the lack of snowfall in the I-95 corridor and saying that within 30 or 40 years that you will have to go to the highest mountaintops in the United States to find any snow at all. And somebody showed me this link, and I just simply replied, "This is beyond the biggest piece of garbage I've ever seen." This is there's been a series of climactic predictions that go back as far as 1980 or 85, and actually even go back before that, and a single one of them has come true. And I bring that up because a lot of that stuff is then used to kind of drive politics. And I really would love to see if we could find a way to get away from that, so that climatologists can do the clean work, clean job, look at the data, and see if they can figure anything out. So I guess I'm not really giving you a position on this because honestly, I don't know what the answer is. Yes, I'm being a politician here. I think some things have changed, but also a lot of things have not. And the question is whether all the stuff that we see over a course of a lifetime, is that all the different weather extremes that could occur? Is a human being's lifetime long enough to see every possibility? 70-degree temperatures in December, snow in April or in May. They're all there at some point, but they all happen. But the thing is, they are usually, as I pointed out before, those are like generational or even multi-generational events. A hurricane like Sandy for Long Island, for example, and for New Jersey, but less so for New Jersey, because Sandy is now your signature storm. You really have to go way back to find the last generational storm of that magnitude. But on Long Island, the 1938 hurricane was the big, standard hurricane, and Sandy in 2012. So it took 74 years between. That's a whole, for 74 years is slightly less than the average lifespan of a human being. So I don't know that you get to see all the extremes. So I guess the bottom line is observed weather and observed weather phenomena is different from climate.
So just one point you were making about forecasts that go out for 16 days, basically they never turn out. How can people come up with models that they project? I don't know that you get 50, 100 years, but the temperature's going to be going on years. When you look at the observations, like you said, it's actually not happening.
Well, I mean, there was the hockey stick analogy. That's now been kind of like, okay, that hasn't happened. I would like somebody to go back and look at this stuff again very cleanly. Well, but we need to go back. That's why I think it's important that we need to have clean data, that somebody can look back and go back now and say, okay, well, why didn't this happen? Okay, if you have a model, the way a model is supposed to work is that it predicts an outcome, but you need to also then look that when that outcome doesn't happen, you got to go back and say, okay, what went wrong? Why, was the model might have been right up to this point, and then it failed. Why did it fail? Well, see, yeah, and you know what? Unfortunately, human beings, we all have agendas. We all do. We all drive. We have all our own ideas of where things are going to go, and it's very hard to find a consensus to be able to work at this sort of stuff, to figure out, what is going on, if something's going on, and this also involves tax policy, and involves all kinds of stuff that, for me, I just want to be able to predict the next snowstorm and get it right. That's kind of how I look at it. Let me get Ryan, then I'll come to you. Go ahead.
Did you ever experience in your
throughout the number of years you were living on Long Island, have you ever experienced ocean effect snow?
Oh yeah, ocean effect is very cool. You see it sometimes on the Jersey Shore too. I get Long Island sound effect snow when I get a very deep, or if I get very bitter cold Arctic air mass that comes down. If I get a north wind off the sound, I've seen it put down like a couple of inches.
What
You
about
know,
when the winters are pretty south?
that's a little different because the water when it's a south wind, it's usually in the process where cold air is decaying, so you don't really have it. It doesn't quite work the same way. It'll happen immediately along the South Shore initially. Sometimes on the south wind, if it's light enough, I get freezing drizzle out of it. Last one, because I think Janet has to go.
That's a little different because the water when it's a south wind, it's
When
usually
did
in
you
the
rate
process
the
where
leaves
cold air
when
is
you were a
decaying,
kid
so you don't really have it. It
versus
doesn't quite
the
work the
last
same
10
way.
years?
Okay, so that's actually very good, very good question. There actually is, the data show. One of the things that's happened over the last 18 or so years, and it might coincide with the fact that the snowier winters could be wrapped into this. The autumns are starting later. Autumns are starting later. Winters as a whole are starting later. There are some exceptions to this. It doesn't not every year, but winters are starting later. They are also extending well into the month of April. We've seen that over the last 4 or 5 years, where the quote unquote winter, winter-like weather, or however you want to describe it in terms of whatever parameter you might use, but there seems to be some sort of decadal, by decadal I mean a 10-year period, a decadal shift in the seasons where the autumns are starting later, the winters are starting a little later, and the springs are starting a little bit later. And the springs are shorter. The transition seasons seem to be a little shorter in duration. They're starting later, lasting less. But there is evidence, at least here in the Northeast, in our area, that actually is happening. I can remember seeing all the leaves down in the Bronx by the middle of October, all the trees bare. Now it's more like early, yeah. Well, yeah, we saw that last year. Well, was it last year or 2 years ago? Where it was last year where basically we flipped a switch right around Thanksgiving, and it turned bitterly cold. I know all the landscapers and snow removal guys were upset because the leaves didn't come down. They couldn't do the fall cleanups, and then all of a sudden it snowed, and it snowed in December, and none of the leaves came down, so they couldn't do any cleanups. But yeah, there is a decadal shift that did occur. I got to say goodbye to my YouTube folks here. We'll see you tomorrow, regular live stream at 7:30.